Hello everybody, this is Enrich Geometry and we are graphing quadratic equations. Fairly late at night, if I may add. Okay, y equals x squared. Oh boy, this is our most basic formula. You can't get any simpler than this and still be a parabola. Okay, if you pick something for x and see what you get for y. Okay, -2 squared means -2 times -2, which is 4. -1 squared is -1 times -1, which is 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. So -2, 4. -1, 1. 0, 0, 1, 1, and 2, 4. Why did I pick those numbers? Well, I knew what I was looking for. I knew I wanted a U shape, and I knew it was the most basic graph, so it would be centered at 0, 0. So basically, I kind of knew ahead of time what to pick. You wouldn't have. So you could have picked any random number and pick a bunch of random numbers until you figure out the vertex and 2 points on either side. You need the vertex and 2 points on either side. This is at a minimum. So if you graph 10 points and they're all on one side, you wouldn't be done. You need the other side too, which by the way, looks the same. So you need a total of 5 points at a minimum. Okay, so that's the basic parabola. So when you graph a quadratic, you get a parabola. Parabolas are U-shaped, so all of these graphs will be U-shaped. Okay, let's try the next one. All right, let's make a table. Pick random numbers. We have to pick enough numbers until we get our U shape. Okay, let's pick, well, -2, -1, 0, 1, and 2. Let's just pick the same numbers we used last time and we'll be done. -2 plus 1 is -1 squared. -1 squared is -1 times -1, which is 1, plus 2 is 3. So at -2, you get 3. -1 plus 1 is 0 squared. Plus 2 is 2. So at -1, you get 2. At 0, 0 plus 1 is 1. Squared is 1. Plus 2 is 3. At 0, you get 3. And at 1, 1 plus 1 is 2. Squared is 4. Plus 2 is 6. At 1, you get 6. 4, 5, 6. I have to extend my graph a little bit. Occasionally, students don't like extending their graphs, but I've never understood why. I've always liked extending my graphs. And at 2, you get 2 plus 1 is 3. Squared is 9. Plus 2 is 11. 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's right about there. And I'm done. Or am I? I don't have enough points on the left side. Interesting. So I wonder if I can keep from having to graph more points. If this point up here is 1, 2 away, I could go 1, 2 this way and put a point there. And now 1, 2, 3, 4, 5, now I have enough points. Interesting. Very interesting. Now, if you look for some patterns. There is an interesting correlation between this 1 and this 2 and the vertex. This vertex is at -1, 2. Okay, notice that this number plus 1, it's the opposite of that. And this number, it's the same. And this is true for all parabolas. So I'm arguing that for this parabola, the vertex so you need to graph the vertex. That will go here. And you have 2 points on either side. So I didn't need this last one. So you need to graph the vertex and 2 points on either side. Now our pattern holds up. The vertex is the opposite of this, comma, this. So the vertex is 2, 3. 2, 3. So now I can plug in 2 points on either side. Or, if you feel like it, you can plug in 2 points on one side and reflect them to the other side. Okay, so 2, 3. That's the vertex. Now I'm going to plug in 1. So it's -2 times 1 minus 2 is -1 squared plus 3. Okay, -1 squared is 1. 1 times -2 is -2. And -2 plus 3 is 1. So I get a 1 here. 1, 1. Now I'll plug in 0. Okay. -2 times 0 minus 2 is -2 squared plus 3. So -2 squared is 4. 4 times -2 is -8. -8 plus 3 is -5. Okay, so I get 0, -5. Now I can flip these to the other side of the parabola. So that's 1 away, that's 2 away, and I'm done. And there's all sorts of patterns we can look for. If there's a negative in front, it always opens down. Okay. If there's a number in front, it changes the shape. It's narrower or wider. All sorts of things. Okay. Now, let's try graphing this one. This one has 2 parentheses. It looks different than the ones above it. Okay, so this one, let's make a table and graph it. All right. Let's plug in, what are my favorite numbers to plug in? -1, -2, -1, 0, 1, and 2. I love those numbers. Okay. Now, -1 times, so I'm going to put -2 here and here. -2 minus 3 is -5, and -2 minus 1 is -3. So -1 times -5 is 5. 5 times -3 is -15. Holy cow. -2, -1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That got even a little ridiculous, even for me. Okay, let's try -1. All right. -1 times -1 minus 3 is -4. And negative 1 minus 1 is negative 2. Negative 1 times negative 4 is 4. 4 times negative 2 is negative 8. Negative 1, negative 4, 5, 6, 7, 8. Right there. Negative 1 times 0 minus 3 is negative 3. And 0 minus 1 is negative 1. Negative 1 times negative 3 is 3. 3 times negative 1 is negative 3. 0, negative 3. Hoofda. 1. Negative 1 times 1 minus 3 is negative 2, and 1 minus 1 is 0. 0 times anything is 0, times anything else is 0. 1, 0. 2. Negative 1 times 2 minus 3 is negative 1, and 2 minus 1 is positive 1. Negative 1 times negative 1 is 1. 1 times 1 is 1. 2, 1. Oh my gosh. I plugged in all of these numbers and I still don't know where the vertex is. I don't see it. Oh, the parabola opens down. Okay, because there's a negative in front. Do you see like the top and where it starts to go back down again? No, we don't. We plugged in all these numbers and we haven't found the vertex yet. Or we might have found the vertex, but it hasn't started going back down yet. So let's try 3. Negative 1 times 3 minus 3 is 0, times 3 minus 1 is 2. Negative 1 times 0 is 0. 0 times 2 is 0. Oh my. There it goes. There's the vertex, and there it starts to go back down. So this point's 2 away. We could go 2 away here and get that point. And there is enough points. Here's your parabola. Okay, now, if all of that guess and check was a little much for you, there is a way to try to figure things out. If there's 2 parentheses, the things that make y 0 will be the x-intercepts. So what makes this part 0? 1. And what makes this part 0? Negative 3. So 1 and negative 3 are the x-intercepts, and negative 3 are the x-intercepts. So if those are the x-intercepts, then the vertex must be in the middle. In the middle, you'd have to go over 2 this way and 2 this way. So negative 1 something is in the middle. So if you plug negative 1 into the equations, negative 1 minus 1 is negative 2. Negative 1 plus 3 is 1. And negative 2 times 1 is negative 2. And then plug in something close by like 0. 0 minus 1 is negative 1. 0 plus 3 is 3. Negative 1 times 3 is 3. So 0, negative 3. What did I say negative 1 was? Negative 1 minus 1 is negative 2. Negative 1 plus 3 is positive 2. Negative 2 times positive 2 is negative 4. I goofed that one up. At negative 1, I get negative 4. At negative 1, I get negative 4. So that's the middle. So if this is 1 away, there's got to be a point 1 away over there because both sides are the same. So there is my parabola. Okay. So if you don't remember what the pattern is, you can just guess random points and be fine. But if you do recognize the pattern, it'll save you time, and you can, and you can then not guess and check. You'll still have to plug in points, but you want to guess at what they are. So if there's the 2 parentheses kind, these are the kind where you can set y equals 0 and solve it. Your two solutions will be 1 and -1. Those are the x-intercepts. So if you have the x-intercepts, now you know where the vertex is. So you still have to make a table and plug in points, but you don't have to guess and check to see where the vertex is. So problems 1 through 4, you can find the x-intercepts. Now, the second kind, 5 through 8, these are the kind where you can get the vertex. So 5 through 8, you can find the vertex. The vertex was the opposite of this number, comma, this number. So the vertex for problem 6 is -2, -1. If you know where the vertex is, you know you could pick points close by, and it'll save you time. But if you forget all this, you can just make a table and guess, and you'll eventually be able to get the parabola.